In this video, I'm going to talk about Desmos. Desmos is an online calculator and actually several other mathematical tools that you may find to be very useful as you progress through high school and college and beyond. It is not a complete replacement for your personal handheld calculator. For one reason, it's generally not used on tests because of the laptop issue. However, you will find that it is being used now on standardized exams, such as the PSAT, SAT, and AP exams. And so knowing Desmos can be helpful for those. But just in general, having Desmos available, if you don't have a calculator or your phone simply available to you, you can use Desmos to do most things that your calculator will do. Not everything, but most things. I'm going to go through a bunch of different things in this video. What I'll do is I will break it down by topic in the description so that you can jump ahead chapter by chapter to whatever is interesting to you. And one thing that's really nice about Desmos is you can just do as little or as much as you want. So there's plenty out there for Desmos to do. But if you don't want to do it all, that's fine too. So let's get started. And here we have the opening screen for Desmos. And you can see down here, it has a bunch of math tools available. We're going to use the graphing calculator today, but there are a couple of other calculators here. It also has a whole different program just for geometry, creating shapes and so forth. So if you're currently taking geometry or you're interested in geometry, you may find those interesting. And then here, 3D, if you're in multivariable world. These are things that we're not going to talk about in this video. Perhaps in other videos, I'll go through them. I'm just going to work with the graphing calculator. In fact, it's got its own dedicated button here as well to open up the graphing calculator. And there it is. And you can see here, you have two different portions on this screen. You have the input lines, which are here on the left, and then the graphing calculator portion, which is over here on the right. And I'll talk about some of these symbols over here. You'll notice here that I have actually signed in to Desmos, so I have an account. And the reason I've done this is so that I can save my work if I like and share it with other people. You can use Desmos for free without an account, and you just can't save things. But if you're using it like a calculator, it shouldn't really make a difference. Let's get started here with the basic expressions. And you'll see here we've got this line, and here's where we can type in something simple. Now, you can use it like a basic calculator, like a 4-function calculator, and do simple addition. So I could type in 2 plus 3, and you'll see that it automatically, I don't have to do enter or anything like that. It tells me that the answer is 5 here. If I do hit a carriage return, it's just going to give me a new line. So I can do some more advanced arithmetic if I want. So for example, I'll put in some parentheses here, 2 plus 7. You'll notice that it gives me the closed parentheses automatically. And I'm going to divide that, and that's just a slash, and you'll see that it creates a divisor. And I'll divide it by, 13 plus 9, something weird. And you'll see that Desmos gives you a decimal answer in this case. If you would like the fraction answer, over here on the left-hand side, there's a little symbol with the fraction. If you click on that, it's going to turn my answer back into the fraction, which is 9/22. And I'm going to hit return, get to something new. Again, you can do some basic stuff here. You could also do like a square root. And square root, actually, you just type square root, SQRT, and it's going to create a square root. And I can say, let's say the square root of 5, and it's going to give me an approximation for the square root of 5. Notice there's no fraction symbol here because you can't write the square root of 5 as a fraction. Other things you can do, let's say log. So if I type log of 1,000, you'll see the answer is 3. Now, this is common log, that is log base 10. If I want something other than log base 10, I can just go back here, initially or now, and do a subscript. Now, to do a subscript is going to be shift underscore. And if you don't remember that, or you're just like, oh, what am I supposed to use for the keyboard shortcuts? If you come over here on the right with the question mark, and you'll see here there is a link for keyboard shortcuts. And if I click on that, there's a ton of them. And I'll just sort of scroll down here. There's a lot of them here. I have not memorized them all, of course. You'll notice that there's two sets, one for Windows and one for Mac. I'm using a Windows-based machine. Most of them are similar. For example, here, if you look for the Windows and the Mac, if I click over to the Mac, they look the same. But down here, we've got a little bit of a difference. So this is Control Command, where in the Windows it's Alt. But otherwise, very similar. And if I want to make a subscript, so here it is, it's going to be an underscore that is Shift and the underscore key. So let's get rid of this, Shift underscore, and now I'll type a number. So let's say 5. So log base 5 of 1,000 is about 4.3. What's really nice here about Desmos is you really don't have to be too particular about syntax. It basically does what you sort of expect it to do. So for example, if I want the sine of something, let's say the sine of 30. Now this seems weird because you might think, wait, the sine of 30, isn't that a half? But that's the sine of 30 degrees, and Desmos defaults to radians. If I want to be in degrees, there's another shortcut for it. It's, at least on the Windows machine, it's Alt-D. And you can see here now that I'm in degree mode. And of course, I can create this as a fraction now because it's 1/2. I'm going to hit Alt-D again, which is sort of strange because it gets you back and forth between degree mode. And now I'm back in radians. And that's perfectly fine. But if I wanted to say the inverse sine of, well, 30 won't work, but let's say inverse sine of 0.3, it's surprisingly just sine inverse, which is the -1. So here it's going to be Shift 6. That's going to get me the superscript. And I just type -1. And there is arc sine. I believe you can also just write arc sine. And arc sine of 0.3 will get you the same thing. And there's a bunch of them. And of course, we can put them together. So I can say, what's the arc sine of 0.3 plus log base 2 of 15, whatever. So it's just a calculator. And if you just need a calculator, this is one way to do it. So I'm going to start clean on a new screen so you don't keep seeing all these input lines that I've already done. And the way I'm going to do that is I'm just going to go here and just say new graph. And that's just going to give me a brand new graph. So if I want to create a point, let's say the point 2, 3, if I just type in parentheses 2, 3, close parentheses, and again, the close parentheses is automatic, you can see my point has appeared here at the point 2, 3. And I can even label this. If I click the little label button, it's going to label it as 2, 3. Or you'll see there's an underscore here, this big blank. I can give it a name. I could just call it, let's say, the point A, and now let's change it to point A. Or if I want to give it some other name, I can do that. If you don't like the color, if you go over to this red, and just for the Windows machine, it's click and hold the left mouse button. I think for a Mac, it's just click the button. And you'll see what happens. It pops up with this submenu, and I can say turn these all into triangles, or I can make them all blue, whatever I like. There's some other things here, which I won't get into. Now, I've got this one point, but I don't have to actually create points that are at a specific spot. If I type in A comma B, you'll see it asks me, do I want sliders for A or B or both? Because Desmos already realizes that I think of A and B as some sort of unknown constant. And if I just say yes to all, it's going to give me 2 sliders, and the point here is the point 1, 1. And if I label that, you can see 1, 1 is showing up. And if I now move A and B, they change right there on the graph. And in fact, it works the other way as well. If I come over here and grab the point and pick it up and move it, you'll see my sliders move as well. So some really nice stuff here just for making points. And again, for the geometry side, it's a whole other thing that will help you if you want to play around with geometry. Now, I can create a bunch of different points here. However, one thing I cannot do is easily just say, here's a bunch of points, what function is it? Because, well, that's not actually an easy thing to do in mathematics. That will take some sort of regression technique, and we'll talk about regression later. But right now, just for creating points, if you want to put a bunch of points out there on a graph, simple enough to do. Now I want to talk about creating a table. So again, I'm going to go to a new graph, and let's create a table. And the way to create a table is by clicking on the plus sign up here, and you'll see that I have a bunch of different options, and I'm going to choose a table. And what it's going to give me is x1 and y1. So x is going to be my independent variable, y is going to be my dependent variable, and I can just type in a bunch of points effectively. And I'm going to do that, and I'll just skip ahead here. And here we go. I now have created a table, and you can see that it's created the points connected to that table. If I don't want to see those points on my screen, this green little dot thing here, if I click on that, it just makes them all go away. The table still stays there, but the dots have gone away. I can do some manipulation with this. For example, I can create a new column here, and my new column will be a new dependent variable, and I can actually base it on the old one. So I could make this, let's say, y1. So y1, and you'll see here that two things. One, I didn't actually have to type anything to make the subscript. It does that automatically. And then second, it doesn't like the fact that I have two y1s, but I'm going to change it in a second. I'm going to make this y1 squared. And all of a sudden, now I've got y1 and y2 both graphed at the same time. Now you might say, well, can I connect the dots? Always a fun little game. And yes, of course you can. We come up, again, I can change the color on these and change the points. And here I can turn on lines. And if I turn on the lines, it's going to connect the dots. Again, it's not creating an equation here. That's not something it'll do. I can also turn on the drag. And if I turn on the drag, what it's going to allow me to do is now move these dots. And so, for example, this first dot here, you're going to see that it is changing over here on my table. You'll notice that the purple dot also follows along. And why is that? Well, this dot is y1 squared. So obviously, if I move y1, I'm going to move y1 squared as well. So again, super easy to do to create a table and to manipulate it with your points. And you can keep going here. Another thing I can do is create an array of points first and then turn that into a table. So for example, I'm going to create an array x and y, and I'm going to use uppercase X just to differentiate it from the other stuff. So I'm going to let capital X be an array. And so for an array, it's going to be brackets, and we start getting a little syntax heavy here. So equals brackets or square bracket, and let's just do the points 1, 2, 3. And I'm going to make uppercase Y -2, 4, 5. And now I'm going to create a new table. So table. And instead of this being x2 and y2, which is the automatic default, I'm going to turn that into capital X, and then this one into capital Y. And you'll notice here, just like above, that these two columns are grayed, and this one as well, it's grayed out. And the reason these are grayed out is because I can't change those because they're based on something else. So for example, I can't change this number because it is y1 squared. So unless I change y1, I can't change y1 squared. Same here. These can't be changed. However, if I come back up in here and say, make this 2.5, then it's going to change it down in my table. Okay, that's it with tables. Again, play with it a little bit more if you like. Let's get into the heart of the matter. I'm going to talk about functions, and then we're going to talk about graphing functions. So let's start from a new screen. To create a function, there's a couple of ways to do it. If you're trying to be function-like, it's f of x. So f of x, and you'll see it's already asking me if I want a slider. I haven't done anything yet. Let's just call something, how about x squared? A nice simple function. Again, this dot turns on and off whether what you graphed, and you can change the color here as well. It was asking me if I want a slider. I don't have anything yet to slide, but I could, just like I did before, add, let's say, a, where a is some constant, put on the slider. It's defaulted a to be 1, and you can see I can move this around. What's really nice, of course, is if I change this to be something like ax squared plus bx plus c, and I turn on all these sliders, now I can easily manipulate A, B, and C to see how they affect how the parabola changes. So for example, here, if I make a negative, the parabola goes down instead of up. And those of you who are in Algebra 2 should learn this or have already learned it, and anybody beyond that, I hope you remember that, etc. Super easy to do to create a function. Now that we're here in functions, let's talk about just the graph itself and how do I change the picture, the physical picture of what I'm seeing. There's a couple things I can do. First of all, super easy just to manipulate it around. If I just move my mouse here, click anywhere, I can move this around so I make it look a little bit better. In the Windows, I have the mouse has got the little wheel. On Mac, you just click and hold and use the slider. But you can see I can zoom in or zoom out as much as I want. So I can sort of do both. And as I zoom in, you'll see the numbers change a little bit. If you want to go back to where you started, there is a home key that's up here. If I click on that, it's going to go back to the original screen. I can also go up here to where it says graph settings. That's the little wrench. And if I open it up, you can see that I can turn the grid on and off. I can actually switch over to polar mode. If you haven't learned what polar is, don't worry about it. But if you have, there's polar for you. Turning on the axes, etc. I can change right here, first of all, the label. If I don't want to call it the x-axis, I can label it anything I want, including x. I can change, this is not the domain because this is not affecting my function. We'll talk about that in a second. But this affects what I'm seeing. So right now I'm seeing negative 10 to 10. So if I want to see negative 5 to 10, changing that. And you can see here, Desmos has manipulated the graph a little bit. I can do the same for y. Here, I can change x and y axis from linear to logarithmic. Now, if you haven't learned logs, if you haven't learned log scales, this may not mean a whole lot to you. But if, for example, I make x logarithmic, boy, it really changes this graph a lot, doesn't it? I'm actually going to turn this off and create a new graph. I'm going to let this one, and now instead of calling it f of x, I'm going to call this just y. And you can do that as well. So I'm going to let y be equal to the log of x. And you'll notice here in log scale, if I ask for the graph of log of x, it looks like a line. If I come back here and I turn off that back to linear, it looks like what we think of as our logarithmic function. And you can play with this both in x and in y. So this one's called a semilog plot. This one's called a log-log plot. And you may have seen those in physics or other science classes. The complex mode, not really going to play around with that. This is, if you want to do some imaginary numbers, you can do that as well. But that's if you want to be on the real imaginary plane. Again, that's something for another time. That's our basics with our graphs and putting some stuff in. Let's talk about a little bit more with the graphing and how nice Desmos is with the graphing. And then I'm going to start playing around with some graphs. So what I'm going to do, let's start with a new screen again. I'm going to create some kind of wacky graph. So let's just do y equals x to the 5th minus x to the 4th plus 2x cubed minus 4x squared. So something going up and down at least, and maybe zoom in here, see if there's anything else. And actually what I'm going to do is, let's move this up a little bit. So I'm going to +1. And so here's the graph that I've just done. It's an infinite graph. Automatically, it's an infinite graph. Again, I've called it y. If I want to, I can call it y1, and I'll talk about how we connect graphs to tables in a little bit. Now you'll notice here that I'm on the graph. So if I hit a carriage return to a new line, I'm not actually on this graph anymore. It's a little confusing, but I'm now starting something new. But if I click on the graph, you'll see I'm back on that input line, and the graph has gotten a little bit darker. You'll also notice some gray points have shown up. They're very hard to see. I'll highlight them here in the video. But for example, right there, there's a little gray point. And what is that? It's a local minimum. So Desmos has automatically found the local mins, maxes, and the intersection points, which is kind of nice. So let's actually move this a little bit so I have a slightly different intersection point. So I just added plus 2x, and that's just shifted it slightly to the right. And you'll see here, there is my maximum. Here is my y-intercept. And down here is my x-intercept, and there's my local mins. Again, these are local mins and local maxes. You'll see also on the graph that there's a little, it looks like a piece of paper with a check mark. What that is if I come over here and click on it, it's going to export that point over into a line. And I can actually label this point if I want to. Call it whatever you want. I can call it local min. And see, it puts it right there. I'm just going to jump ahead a little bit for those of you who are taking calculus or beyond. I just want to remind you that in the calculus world, while it's great that Desmos will find local mins and local maxes for you, that's not how we find them in calculus. So if you've been asked to find a local min or max, you actually have to use calculus to do that, not just Desmos. Desmos is a nice way to check your work, but it's not a way to do your work. Again, go back to the graph here. There is my x-intercept, and I can click on that and then click here, and it'll export that point if I want. Super nice, really easy to do. Let's talk about limiting our domain and range on this graph. So right now it goes on forever. What if I wanted to limit that? I'm going to get rid of this point. Actually, I'm going to get rid of these couple extras. They're not there doing anything. And the way to create a domain and range, and again, a little syntaxy here, is as soon as we've written the equation, no other symbols after that except for some braces. So a brace or a squiggly bracket. If I then tell it what I want the domain to be, I can do it for x and y, or x or y, one or both. So let's say I want x to only go between, let's say, negative 0.5 and 1.5. So I'll just type negative 0.5 less than x less than 1.5. And now you'll see here, I'm going to bring this down, I have now created a domain for my function. If I want a range as well, another set of curly braces. Again, you don't need a comma or anything like that after the braces. And now let's do the y values. So let's make y go between negative 0.6 less than y less than, and you'll notice while I'm in the middle of it, it disappears. It'll come back in a second. Less than 3. And now I have limited the range of my function. So domain and range, easy enough to do, just remembering these braces. Again, simple to forget. This is why you want to play around with Desmos. The more you do it, the more you'll remember how to do it. We can create multiple functions at once. So once I've created y, come down here, I can create a new one. For example, I'll call the next one y1. So y, if I just type 1, it's automatically going to subscript it. And I can make this equal to x, or I can make it equal to x1. So I can make this x1 squared minus 5. And again, both here are in red, so we'll just make that one green. And you can keep adding more functions on here as you like, as many as you want. You can even, what's really nice, actually better than the TIs in a little bit, I can make this as a function of x. So I could say, for example, x2 is equal to y squared. And you'll notice here that it has created the relationship. It's not a function anymore because you're seeing the top and the bottom, the relationship of x to y rather than y to x. What's especially nice is that I've got two functions happening at the same time. So I've got both y equals x squared and x equals y squared, and plus my crazy quintic up here, all happening at the same time. And look, there's the intersection between those two graphs. So if I click on that, it's found the intersection between these two completely different functions. Something we often ask students to do, and something you might need to do, but it's done for you in Desmos. while we're here on functions, let's clean this up. I'm going to start with a new graph again. And let's talk about inequalities in functions, which is kind of cool that Desmos will do that as well. So, for example, if I want not just y equals x squared, but y is greater than x squared, the way you do that is just, not too surprisingly, use a greater than sign. Y is greater than x squared. And there we have it. There's y greater than x squared. You'll see that it's even given me the dashed line because it's greater than x squared, not greater than or equal to x squared. If you want greater than or equal to, just come back here and type an equal sign. You'll see that Desmos combines those to make it a greater than or equal to symbol. So even though I just typed the equals key, it turned it into greater than or equal to, and there is my solid line, y is greater than x squared. I could also do, on the next line, let's say y is less than, and we'll just leave it as less than, x squared plus 2. Actually, let's make that negative x squared plus 2. That's going to be a little bit more interesting. And now where it's purple-ish is the intersection of those two. Again, another question that we often ask students to do and something you might be interested in doing to create these different areas for a system of inequalities. Now, there's actually another way to do a system of inequalities. It's not quite as nice because here we've got the dashed lines showing. I can do it by playing around with my domain and range, like I showed you earlier, to create a system of inequalities. So let's get rid of this. And I'll, let's say, want this to be less than y equals x plus 1. And so now what I want is a system of inequalities. Well, before, when I did the domain and range, I gave it constant limits. So for example, I said y was between -2 and 2. But you can give it function limits. So I could say, again, curly brace, y is less than x plus 1. And you'll see here that it has now created this, not really a domain anymore, because now it's bounded by another function. And actually, I can do as many of these as I want. So I could also say that y is less than negative x plus 2. And you'll see it's cut it down there. Now, the one disadvantage that this has is you'll notice that it's not giving me the dashed or solid lines because these are limiting the function, not creating a series of functions. But effectively, it's acting like a system of inequalities, which is kind of nice. All right, I've already showed you that Desmos can work both explicitly and implicitly. So, for example, let's just get rid of this. I can do y equals x squared or x equals y squared, but I can get even crazier than that. I can do x squared plus 2y squared equals 1, and it creates an ellipse. I can also just change this to be ax squared plus by squared, or if you would like to be in the more traditional form of an ellipse, let's make this divided by a and divided by b. Now, it's technically a squared and b squared for our standardized form. And I could do that too here. And we'll turn those on. And you'll see when they're both 1, we get a circle. And as I move these around, I can play around with my ellipse. Now, what's nice is I can make these a squared and b squared, and it works the same. However, if I make this a and b like I had before, you'll notice that what happens is you move them, it goes between an ellipse and a hyperbola, depending on whether a is positive or negative. And it just shows the relationship between those two functions. Again, if you have not studied quadratic functions yet, don't worry about it. But if you have, it's a nice little thing that you can do here in Desmos. Also, we can do a system of equations. So now let's make the circle. That's always a fun one to do. So x squared plus y squared equals 6. And there's my baseball. And one of the questions that we always ask students is, find the intersection of those two. Well, Desmos has done that for me. You can see the little gray dots. They're a little bit challenging to see there, but there's one. And there's one of my intersections between these two implicit equations, my two quadratic equations. The last thing that I want to show you is piecewise functions. And this is a bit of a pain to do. It is very syntax heavy, but nice if you need to do a piecewise. I'm going to come again, start with a new graph. And this piecewise, I'm going to do 2 lines and then a semicircle here. And I'll just type it all in and then you'll see what we've got. I'm going to use the fx notation here. And to create a piecewise function, we have to do the whole thing in braces. So my curly brackets or braces. I'm not really sure why it automatically defaults to 1 here. Although interestingly, that's going to be my first piece is going to be at 1. So the syntax is the domain and then the function, which seems a little backwards to me, but that's the way it goes. So I'm going to want this one to go between -2 and 0. So I'm going to do -2 less than, actually I'll make it less than or equal to x less than 0, and then colon what the function is. And I want this one to be 1. So there is my first piece. And now after that, it's a comma. So comma, second piece, third piece. So my next one is going to be between 0 and 1. So we're going to do 0 less than or equal to x less than 1, colon. And this one is going to be -x plus 1, comma. And then the last piece here, it's going to be between 1 less than or equal to x less than, actually make this one less than or equal to 3, colon. And then the function here is going to be the square root, so sqrt, square root of 1 minus, and then 1x minus 2 squared, so parentheses x minus 2 squared. And so here we have a piecewise function that is this horizontal line, and then the slanted line, and then the semicircle. You can't do some of the other manipulations you can do with functions, but this is kind of nice. So that's our basic stuff with the basic calculator and a lot of the graphing, and this is going to be what's helping most students out. We'll do a little bit more, some stuff that you may not need to do until much later in your career, or maybe never. So what I'm going to do now is some regression techniques. I'm going to talk about turning functions into tables, and then turning tables into functions using regression. And then I'm going to do a little bit of calculus. So if you have not gotten to any of those yet and you're not ready for it, this is a good time to end. But if you know about these things, please feel to continue watching. So let's start with functions into tables and then tables into functions. So if I want to create a function into a table, that's actually really easy to do. So let's do y equals x squared again. So I'm going to actually call it y1. It's going to be helpful for the table. y1 equals x1 squared. And now create a table. And now you'll notice here it's told me x2 and y2 because I've already used x1 and y1. But actually I want it to be x1, and I can start filling in the table as necessary because I've already defined the function here, and so that way I can create a table based on that. The question is more interesting the other way, which is how do I create a function from a table of values? So let's do that. So I'm going to create a new table here, and now x2, y2 is good. And let's just pick a bunch of different points. And here we have a table of points, and you can see them graphed. I chose a bunch of points that are supposed to look kind of exponential, and I'll show you why I did that in a second. So now the question is, can I turn these points into a function? So how do I do that? Well, come over here, and you'll see this little symbol that looks like points around a line. And I'm going to click on that, and it says add a regression. And you can see here, it's given me linear regression, which doesn't look so great. Down here with the statistics, so my R squared, my R values, 0.7, that's not really good. I want that to be as close to 1 as possible. So I could choose, for example, a quadratic. That's actually gotten a lot better to a 0.9, and you can see it's mostly fit those points. I can even get a exponential regression. And there's 0.97, and it is supposed to look kind of exponential. All right. And you'll see here, it's even given me the equation. And if I click on here, it's going to move the equation into its own line. So one way to do this regression is just basically ask Desmos to make it into a regression. Now, down here we have the residuals plot, and that's there. What a residual is the difference between my point and the graph. So you can see here, I'm actually a little bit below. My point is below my estimated function. And so down here, my residual is below that. Not hard to do. And again, what's really nice is that you can play around really easily with choosing different types of regressions. So maybe it's linear, maybe it's logarithmic, maybe you would like to just figure out what it should be. The log mode down here is just a way because of this exponential regression, and I'm not going to get into that. But if you're interested, I encourage you to explore it. But you'll see there's a little question mark here. And if I click on that, it's going to open up a help file and explain that to me. So that's a little bit on regression. The last thing I want to do is some basic calculus. So let's clean this up one last time. Now, Desmos is not a computer algebra system like Mathematica or like some of the CAS calculators, the TI Inspires, the TI 89, etc., that do actual calculus. What Desmos is going to do is numerical calculus. It will not find a derivative for you. It will not find an integral for you in general. It will find numerical values of those. So, for example, if I say, let's just make a function, let's do f of x equals x to the fourth, and there's x to the fourth, that's fine. Desmos will not say, oh, the derivative of this is 4x cubed. And again, if you haven't done calculus yet, don't worry about why that is. But if you have, you should know that that's the derivative. However, I can plot the derivative. So I can say y is equal to f prime of x, and you'll see that it has graphed the derivative, which is x cubed, 4x cubed actually. And I can even do the second derivative here, come down one more, y equals f double prime of x, and there's the second derivative. But it's not telling me what the derivative is, it's simply graphing those. So I could pick points and create a table, etc., but it's not finding the function. Similarly, Desmos will not find an indefinite integral, but it will find a definite integral. So if I wanted to do the integral from, let's say, 0 to 2 of x to the fourth, that's my f of x, I can come down here and ask it for an integral. Integral is actually just int, and let's say 0 to 2 of f of x. We still need a dx, and it calculated for me numerically. It's 6.4, so it should be x to the fifth over 5 at 2. So 2 to the fifth is 32 over 5, which is 6.4. Man, it worked out nicely. Okay. Again, it's not going to tell you what the integral is. It's going to find a numeric approximation of the integral like your TI 84 calculator will do and other calculators like that. If you want to actually find the integral, then you're going to need either a CAS calculator or Wolfram Alpha or Mathematica. One of those things will actually help you find an integral. You can also do sums here. Very nice, again, if you are starting with calculus, but it's not doing calculus. So I can't find an infinite sum here because it doesn't know what infinity is, but it'll do a sum. The command for sum is sum, S-U-M. So there's a sum, and let's do 1 to 100 of, well, let's just do n. So that is add up the first 100 integers, and you probably learned this in Algebra 2. You can see the number there is 5,050. I can even do, let's say, 1 over n squared, and that's about 1.63. But that's not an infinite sum, it's a finite sum. You can approximate an infinite sum a little bit better by just making this number really big. And so if we go up to 100,000, that's 1.644, but it's a numeric approximation. What number is that? Well, it turns out, if you don't know, that's pi, and pi is just by typing pi, you get pi. Pi squared divided by 6, and oh, look, it's almost the exact same number there. That's exact. The sum is an approximation. So the sum from 1 to infinity of 1 over n squared is pi squared over 6. Cool little fact that you may learn when you get to calculus. Okay, that's the basics of Desmos across the board. Spent a lot of time here. I hope you've skipped around and found what you thought was interesting and useful. Come back to this video if necessary. But again, always come back. If you want to play with Desmos, just come up to the help file here and it'll tell you how to do some stuff, plus some resources here. So Desmos, super easy to use, helpful for PSATs, SATs, and APs. So I would get to know it a little bit and have fun with it.